All right, this is a little review of long division and synthetic division of polynomials. What we're going to start off with is an example using long division of dividing x minus 3 into this cubic polynomial. So this algorithm looks a lot like long division with numbers. And so what you do is you look at this first term, 6x cubed, and you say, okay, how would I get this thing? What would I multiply this by to turn this leading term into 6x cubed? Well, so you notice if I were to multiply this first term by 6x squared, then that would turn the first term anyway into 6x cubed. And so what you do is you put 6x squared up there. Now let's multiply 6x squared by x, and you get the 6x cubed. And 6x squared times negative 3 would give you negative 18x squared. And like you do with long division with numbers, you then subtract that thing that you just made from the expression above. By design, the 6x cubes go away, and you have minus 25x squared, and then minus a minus 18x squared. So that's going to leave us with a minus 7x squared. And then you simply bring down the next term from above. And so now we have this expression minus 7x squared plus 18x. You play the same game. You think, okay, what would I multiply this leading term by to make minus 7x squared? Well, clearly if I multiplied by minus 7x, multiplied this x by that would do it. And so if you put minus 7x up here, you'd say minus 7x times x would give you minus 7x squared. And then you do the same thing with this minus 3. Minus 7x times minus 3 would give you plus 21x. And as before, you subtract that away. By design, the minus 7x squareds go away. And you have 18x minus 21x. And that, of course, will give you negative 3x. And then you carry down this 9. And then you can see that you play the same game. We need to say, what do we multiply this leading term by to make negative 3x? Well, clearly that's just negative 3. And so if you multiply negative 3 times x, that will give you negative 3x. And negative 3 times negative 3 would give you positive 9. Well, you can see here that when you subtract this off, that goes to 0. And so we have no remainder. And so our final answer for this cubic polynomial divided by x minus 3 is this quadratic that you see here. So that's long division. Let's look at that exact same problem, but we're going to use synthetic division instead. So what we're going to do again is divide x minus 3 into this cubic polynomial. It's actually the same problem we did before. With synthetic division, the algorithm goes like this. So one of the root that sort of corresponds with this factor would be 3. And so you put the 3 right here. If this were x plus 3, you would put a negative 3 here. And then what you do is you put a little, just symbols or notation, we'll just kind of partition this guy off. And then what we're going to do is we're going to peel off all the coefficients. So we have 6, minus 25, 18, and 9. And then what we're going to do, draw a little bar and bring this 6 straight down. And so then what you do is you say, okay, 6 times 3 gives you 18. You put it here. You add these two things together. So minus 25 plus 18 will give you minus 7. And then you say minus 7 times 3 would give you minus 21. And then you add these two things together, giving you negative 3. And then negative 3 times 3 will give you negative 9. And we add those together, you get 0. And so these are the coefficients of the quadratic polynomial that you get when you divide x minus 3 into this cubic. And so you're left with the same answer that we got before, right? 6x squared minus 7x minus 3. So just flashing back to what we did before, that's when we did the long division. And now working, so 6x squared minus 7x minus 3, and then going through the synthetic division, you notice we get the exact same thing following that process. So I'm going to set up one more synthetic division problem just so you get a chance to see one scenario that pops up. Now what we're going to do is we're going to divide x minus 2 into this quartic or fourth order polynomial. So you may want to pause the video here and give it a try. try to follow the synthetic division algorithm, but we'll go ahead and do it now. So what you want to do is the little root or that would go along with this factor x minus 2 would be positive 2. So you put the positive 2 down and kind of partition it off. And then if you remember, the next thing we did was write down all the coefficients. So let's write down all the coefficients. Well, you notice one of these here I've put in red. Well, that's because the coefficient of your fourth order term is 1. Well, there is no cubic term. And so we need a placeholder for that one. So that's something to look out for. The coefficient of our quadratic term is 3, and then you have -9 for the linear term, and then plus 2. And so now let's go through this process. Draw your little line, bring the first coefficient down, and then 1 times 2 gives you 2. 0 plus 2 makes 2. 2 times 2 will give you 4. 3 plus 4 will give you 7. 7 times 2 will give you 14. -9 plus 14 will give you positive 5. Right? Now, if you look at where we are now, we're dividing a linear expression into a quartic or fourth order. And so you know the first term of the quotient is going to be cubic. So we have cubic, third order, second order, first order. This would be the constant. Well, so you can see where this x minus 2 is not going to go perfectly in here. We're going to have a remainder, okay? But you continue this process as we saw before. 5 times 2 will give you 10. 2 plus 10 gives you 12. And so this is going to be part of the remainder. And so then now what we can do is write down our coefficient of our cubic term is 1, coefficient of our quadratic term 2, linear term 7, we get the constant of 5, and then this is our remainder. So we need to tack that on as plus 12 divided by x minus 2, because this was what was left over. So you have this kind of fraction remaining, 12 divided by x minus 2. And so that's the algorithm for synthetic division. And this is the case where the expression x minus 2 did not divide perfectly into this fourth order polynomial, and so you are left with a remainder.